Welcome to 13 Cubed. In this episode, we're going to take a look at Impacket. Well, specifically, we're going to take a look at 5 tools within the Impacket suite that allow us to remotely execute commands and programs against target systems. We'll start off on our Windows 10 attacker box, and after we run each of these commands, we'll hop over to the target, which is a Server 2019 box, and take a look at the various Windows event IDs that will be created within different Windows event logs. We'll look at things that will be enabled by default without any additional configuration needed, even though that never really happens in the real world because everyone always has all of the auditing options configured correctly. No, they don't. I'm just kidding. And we'll look at things that will require additional configuration, like process auditing with command line and scheduled task creation and deletion within the security log, things like that. Either way, the end goal here is to determine exactly what it is that we should be looking for to determine whether or not that system may have been the recipient of one of these Impacket remote code execution tools. So I think this information will obviously not only be beneficial for forensicators, but also for blue teamers and defenders alike. And there's more. If you check this video's description, you'll find a link to a cheat sheet that nicely summarizes all the information we're going to cover within this episode into one nice handy guide. So make sure and download a copy of that. All right, with all of that out of the way, let's get started. I've got a Visual Studio Code document pulled up here, as you can see, and I've got all the notes for the commands that we're going to be running, starting with atexec. And you can see the command line for atexec right here. This is what we're going to be running. So let's unpack this a bit. We've got Python, followed by atexec.py. So far, pretty self-explanatory. We've got the domain /the user, which is going to be 13cubed /Bobby, colon, and then the password, in this case, temp bang1. So that's the username and password of the user that we're going to use to authenticate to the target or victim machine. An @ sign, and then the IP address or FQDN or hostname or whatever gets you there to the target. And then the command that we want to run, in this case, systeminfo. Systeminfo is just something I decided to use in the lab environment because it produces a good bit of output that we can determine whether or not something's working, right? You could put anything there, but the point is this does require a command to execute, no shell. What do I mean by that? Well, I mean that you can't leave off systeminfo and then expect to get a shell like you can with dcomexec or some of the other tools we're going to look at, and the reason why will become apparent in just a moment. As far as what this does, it creates and subsequently deletes a scheduled task on the target machine with a random 8-character mixed case alpha string, not alphanumeric, but alpha. The task runs cmd.exe with the arguments of /c, followed by the command specified, which in our case will be systeminfo, followed by c windows temp, and then you'll notice those x's.temp. So the x's are just a placeholder for that same random 8-character mixed case alpha string. Whatever that string is, it's going to be that same string right here, .temp. And then we're taking 2 greater than &1, which simply redirects standard error to standard output. So again, that X placeholder that you see here is the same random 8-character mixed case alpha string that was used for the scheduled task name. After it's done, it's going to subsequently delete the .temp file containing the command output after that command output is returned to us, that is. Now, notice that this is not detected and blocked by Defender by default. I do have Defender turned off on this lab machine for the purposes of our test, but this, in my test, was not detected and blocked even if Defender were enabled. Okay, so let's go ahead and grab the command line and copy it, and then let's go over to our attacker machine here, and let's paste this in, and press enter. So if we give this just a couple of seconds, you're going to see exactly what's happening here. All right, so here's the command output returned. Notice that it starts off by saying this will only work on Windows Vista and later. Here is, in our case, the random alpha string that was created for the scheduled task. You can see it right here. So you see it's creating, running, deleting, and then it's attempting to read admin $, which of course is c:/windows /temp/ and then that same string that was used for the scheduled task name .tmp. This file contains the command output that you're looking at, which starts right here. So all of this command output that was returned from systeminfo, which is the command I chose to run, was stored in this temp file temporarily until it was returned to us and displayed to standard out on our attacker machine. And that's exactly what we have here. All right, so let's go back to the VS Code document and take a look at what should happen. So we should have 2 rounds of 4776, 4672, and a 4624 type 3, all in the security log on the target for the user specified in the command, which in our case is the user 13cubed/Bobby. So the Bobby user on the 13cube domain. And so we're going to have that 4776, 4672, and 4624, and then another round of that for whatever reason. I don't know why there's 2 rounds. In my testing, there were always 2 rounds. Your results may vary in the real world, but I would expect at least 1 round of that 4776, 4672, and a 4624 type 3. After that, if enabled, we'll have event ID 4698. Event ID 4698 will track scheduled task creations. There are also some other event IDs there that relate to scheduled tasks in the security log. These are not enabled by default, but if so, you'll have that there. You'll also have event IDs 106, 325, 129, 100, 200, 110, 141, 111, 201, and 202, all in the ancillary Microsoft Windows Task Scheduler operational log on the target. So all of those will be there, and that, of course, will be there by default. You'll also have, again, if enabled, 4688, which is, of course, process auditing. And you'll see svc host.exe, calling cmd.exe/c, the command, and then you'll have that redirection to C Windows temp, that 8-character alpha string we talked about, and then the redirection of standard error to standard output. Then you'll have cmd spawning conhost, and then finally a 4699. If enabled, you'll also have the 4688 for whatever binary you're running. So if you're running something like system info, you'll have cmd.exe running system info. XXX is just a placeholder here, of course. And then finally, you'll have a couple of 4634 type 3s, log-offs, to end the 2 log-ons. So in other words, this and this are closed here and here. If an external binary is called, event IDs 201 and 102 may appear later in the Microsoft Windows Task Scheduler operational log on the target. So they may be slightly delayed and out of order. So don't expect to see them necessarily clustered around the other ones that we specify right up here. So this is just a note. I know I've lumped them all together here, but just know that 201 and 102 may lag behind just a little bit. So let's go ahead and go over to the Server 2019 box, which you can see right here. And you'll notice that on my screen, 8:51 local time, 8:51:11 specifically, was the most recent log. So let me press F5 and refresh this. And then we'll scroll back down to where that was and kind of go up from there. So let's see if we can find the start of what we're supposed to be looking for here. So let's go ahead and look at, if we just start going up from here, what we're looking for is the first activity for the Bobby user that we are specifying in the command. So if we continue to go up here, we should see that here right at the time I started it. And of course, if I was smart, I would have just noted the exact time I ran it and then gone right to that time in this log, but I did not do that. So let's just go ahead and do it right here. All right. So here's a 4776 right here, 4776. Notice that the log on account is specified as Bobby. If we go back to here, that is indeed what we're supposed to be looking for, 4776. Then if we go up 1, we should have a 4672, and there it is. So you can see special privileges assigned to new logon or 13cube/Bobby right there. And then if we go up again, we'll have the 4624 type 3 right there for the Bobby user. Okay. Now, if we go up again, check it out. There's a repeat, 4776, 4672, 4624 type 3, just like our notes said. Okay, so that takes us to here. The next thing that we should see, if enabled, is 4698. Let's switch over and see if we see a 4698. If we go up 1, there it is. I do have this being audited, and you'll see that a scheduled task was created, is displayed here in the security log. Again, not on by default, but you can clearly see 13cube/Bobby. You can see the task name, which matched exactly what we saw when we ran the command from our attacker machine. And you can see all of the details regarding that particular scheduled task Most importantly, you'll take a look at the exec section here and you can see the command cmd.exe/c systeminfo greater than to redirect the output into that file that we just talked about. So exactly what you're seeing on the attacker machine is what you're seeing here on the victim machine in terms of the command being run. Okay. What next? Well, we should have a bunch of different logs in task scheduler operational, but we'll come back to that. That's a different event log, right? So we should see some 4688s because I do have process auditing enabled. So if we go up, sure enough, there's a 4688. This is for cmd.exe. And you'll notice that the new process name is actually listed as CMD, but the creator process name is SVC host. And then you'll see the process command line because I am auditing that as well. Remember, you can enable process tracking, but you have to explicitly enable command line as well. Otherwise, you'll just get the process itself, but not the full process command line. In my case, I've done it quote unquote correctly, right? And I've got the whole thing being audited. But you can see cmd.exe/c systeminfo, and then you can see exactly that same command line there in the 4688. If we go up from there, there's another 4688 where we see the new process of conhost. So cmd spawning conhost, which is exactly what we expect to see. If we go up from there, we have a 4699, which is our scheduled task being deleted, just like we said. So here's the task being deleted. If we go up again, we have the 4688. Again, the task being deleted kind of happens in the middle of all of this, but here's the 4688 for CMD spawning system info. So that's the command that we specified, right? We told it to run system info. And you'll notice the process command line is just system info because that's literally all I told it to run. And if we go up from here, finally, here's our 4634 type 3 for the log off. And we should see one more. Yep, there's the other one. So there's two different ones. And if I go back and forth, you'll see there are indeed two 4634 type 3s. And that's pretty much it. So that's the entire sequence of events located within the security log. But remember, there's also the Microsoft Windows Task Scheduler operational log. So if we go over to this, and then we go ahead and refresh that information and scroll down, we should see starting around right here, here is event ID 106. So this is a new scheduled task being registered or created by 13cube/Bobby. And you can see the name of the task right there. And then, of course, you've got a queued message. So that scheduled task is being queued right here. And then, of course, you've got several other ones, 129, 100, 200, 110, 141, 111. And then notice the 201 and the 102, which kind of lagged behind. So the last two were the 201 and the 102, which matches exactly what I said here. If an external binary isn't called, then 201 and 102 may appear later, as in more recently. And that's exactly what we saw there. So hopefully that makes sense, right? That's both sides of the story, right? You looked at the attacker and you saw the attacker running the command and what a sample command line would look like. And then you saw all of those resultant logs. Now, here's the good news. The good news is you don't have to take screenshots of this video or try to remember all of this because guess what? I'm giving you a cheat sheet along with this video so that you don't have to commit this to memory or print out ugly screenshots. You'll actually have all of this in a nice, neat cheat sheet. So check this video's description and you'll find a download to that. So moving on, what do we have next? dcomexec. So dcomexec is a little bit different. First off, let's take a look at the command line. We've got Python, dcomexec.py, makes pretty logical sense. In this case, we're going to specify -object mmc20. I'm not going to get into the different decom objects, but just note that you can use things like shell windows, shell browser window, mmc20, and those are just general parameters you're going to see with the object parameter. In terms of what all of that means, that's a topic for another video, but if you want to learn more about that, check the video's description. I'll put a link to learn more about decom and exactly what those decom objects mean. But just know in our case, we're using the decom object of mmc20 for specifying the same username :password that we did in the previous command at, then we're specifying of course, the target, and then system info. But notice here I said that you can specify a command to run, which is what we're doing, or you can leave it blank and actually get a remote shell. So again, you can leave system info off from our command line here and actually end up getting a remote shell. So let's go ahead and grab this we'll go over to our remote desktop session here. We'll clear the screen here, paste this in, and in just a couple of seconds, we should also get the same system info returned to screen. And here it is. So let's take a look. If we go up at the very top, there's not a whole lot of interesting output. You'll see the SMBV 3.0 dialect used message here, and then you'll see the output of system info, just like that. And of course, if we go over to the target machine, we're going to see those same logs. What exactly are we going to see? Well, we're going to see the 4776, 4672, and 4624 type 3 for, in our case, the Bobby user. Again, 2 rounds of that, just like we did with atexec. If enabled, we'll see a 4688 with svc host.exe executing mmc.exe-embedding. I also saw in my lab test another 4776, 4672, and 4624 type 3. So another round right before we see all of the 4688s here. And these 4688s are going to be of particular interest because there's some unique command lines here starting right here. You can see MMC calling cmd/q/c cd /. Then you'll notice this one greater than. Then you'll see / 127001 admin $, and then this. This is a pretty unique string. Specifically looking for at least this in an environment might yield some interesting results. So if you're able to use, a sim like Splunk or something like that to look at process command lines, and you see a command line of cmd.exe/q/c cd /, and then you see this exact redirection here with 127001 admin $, that is a telltale sign of potential usage of dcomexec. This, no matter what command you run up here, in our case, system info, but no matter what command, you're going to see this cd /, cd, and then finally the command. So again, these are always going to be present no matter the command you run. You're going to have these 2 rounds of cmd.exe and conhost, cmd.exe and conhost. The first is cd /, the second is cd. I'm not exactly sure why the tool behaves this way. I don't know why it needs to execute cd / and cd first, but that in my testing was always present no matter the command being run. I've seen this misinterpreted before. I've made this mistake before thinking that the threat actor actually entered cd / and cd. But again, that seemed to be default behavior of the tool. And then finally, we had cmd.exe specifying the actual command that we wanted to run. In our example, again, system info. But you can see how this command line, or at least part of it, could be something that you would want to use as a nice high quality indicator that this tool is in use. And then finally, you see a couple of type 3s. Now, again, I told you I wasn't going to go through every one of these, but let's just go back to the security log here and refresh this and take a look and see if we can see. I'll just start at the top and go down, and I'll show you at least a couple of things here with regards to what this is going to look like. So let's go ahead and find our 4688 that we're talking about here. All right, and so you can see, and again, we're going from newest to oldest in this case, but you can see, let's see, that is actually noise, so let's ignore that one. Let's go down and find, there we go. So here is our system info. Here is right here. So this is what I'm talking about here. Here's the process command line, cmd.exe/q/c system info. And you can see that redirection here right after that, then the / 127001 admin $. So you can see exactly what I was referring to in that text document. And again, if we go backwards in time, you'll see there's cd, and then the one before that was cd /. You can see it right there. So again, just to show you that that does hold true. I'm not going to go back and forth for every one of these and show you, but that's all there is to it. That's exactly how you can detect the usage of dcomexec. What about psexec? Well, let's take a look at the command line. So we've got Python, psexec.py, again, username, password, @host, and the command to specify. Notice that you can specify a command, or just like dcomexec, you can leave it blank and get a shell. So again, you couldn't do that with atexec, but you can with dcomexec and psexec. Psexec is going to create and subsequently delete a service with a random 4-character mixed case alpha name pointing to an 8-character mixed case alpha.exe file in admin $c:/Windows. This is detected and blocked by Defender by default in my tests. So let's go ahead and run it and then talk about what you can expect to find on the target. So again, I'm going to grab the command line to here. I'm going to go back to RDCman, clear the screen again, paste this, and there we go. The first time I ran it, I had a trailing backslash there that I accidentally typed, if you noticed that, but I ran it again and you can see the output. So what do we have here? Well, requesting shares on target IP, found writable share, admin $, uploading file, random 8-character alpha.exe, opening SVC manager, creating service, pghk, again, 4-character random alpha, starting service, and then finally, we have all of the output right here, just like we did before. So, by the way, at the bottom, you can actually see where it stops the service, removes the service, and removes the file, cleaning up after itself. All right, so what do we have here? Well, we have a 4776, 4672, and 4624 type 3, and then it should come as no surprise that we should have a 7045 for a new service in system. So again, not looking at every one of these logs, but if we go here and go to system and then refresh this and then go up to the very top, we should have, I think I just saw it right there. There's actually the stop for it, but there we go. 7045, a service was installed on the system, service name pghk, and you can see the service file name is %system_root%, which is c:/Windows, and then you can see that random alpha string of 8 characters right there. So there's your 7045. There's actually a 7036 showing that it entered the running state, and then you have a 7036 showing that it entered the stop state. All right, so let's take a look at this. So again, showing the 7036s, in addition to the 7045, showing a 4688, where you're going to see services spawning C Windows xxxx 8 characters.exe. Then you'll have more rounds of 4776, 4672, and 4624 type 3. So you see those 2 or 3 different rounds of authentication there. Then you'll have another 4688 for the C Windows binary greater than command. And then another one for CMD spawning conhost. And again, in my observation, I saw numerous other 4624, 4634s, and 4672s for that same user I specified. So there may be multiple rounds of that. But the point being is you're looking for 4624 type 3s and then 4634 log-offs for the user that would have been specified by the attacker within that psexec command line. You're looking for service-related information in the form of 7045s and 7036s. And again, the key takeaway here is that let's go over this again to make sure that we understand that there's a 4-character random mixed case alpha name. That's the service name, pointing to an 8-character mixed case alpha exe file. Got that? That's the key takeaway here. 4-character service, 8-character executable. And again, your best friends here are going to be the system log with those 7045s and 7036s, and of course the security log in terms of showing you the authentication and hopefully process auditing if you have that enabled. So that's psexec. Let's move down to smbexec. smbexec works like this. Again, this part should be very familiar. I'm not going to go over this again. There is no option to specify a command to run. So again, I can't tack on a system info after this. I'll prove that to you in just a second. There's no option to specify a command to run. You just get the shell. This creates and subsequently deletes a service named BTO. BTO. I am guessing that sounds familiar to some of you watching this right now. You've probably seen a service called BTO. BTO. That is always, unless changed, the default service name, BTO, BTO, and it's going to point to execute.bat for every command entered into the shell. This is detected and blocked by Defender by default in my tests. The command entered into the shell after echo. So we're going to talk about that. CD is executed by default. the first time the connection is established. This is not something that was typed into the shell. This is a key takeaway when you see that CD. We'll unpack this in just a second, but let's go ahead. Let me make sure I copied that to the clipboard. So let's copy this right here. Let's go over to our attacker machine. Let's clear the screen. I just want to show you, if I type system info here, it's not going to work, right? Unrecognized arguments, system info. So again, no option to specify command to run. But if I do this, check it out. Launching semi-interactive shell. So if I type hostname, you'll see that we are indeed on the Windows 2019 box at this point. Now, if I type exit and then type hostname, we're back on the Win10 test VM. So I actually got a remote shell doing that with smbexec. All right, so let's go back to our handy little document here and take a look at what we should see. Of course, the 4776, 4672, and 4624 type 3. I'm sure you're sick of me saying that. Let's check out that 7045. That should definitely be easy to find. So let's go over here. Let's go to system. Let's refresh what we have here, and let's find it. All right, there we go. 7045, service name, BTO. Check out the command line. %comspec%/q echo, then my command hostname, and then you'll notice all of this long string here where we've got execute.bat being called and subsequently deleted. So let's go back to our document and take a look at this. So there's the 7045 right there. If enabled, we're also going to have 4688s, and you're going to see services.exe executing right here. cmd.exe/q/c echo. You're going to see first the CD. Even though we did not type in CD, I promise you it will be there. I will show you in just a moment. Then you're going to have this redirection again. Again, this is a very unique string that you could grep through or search through in your SIM looking for this kind of command line right here. This, in fact, this entire string right here should be a pretty high fidelity string to search for, right? So, in fact, it continues actually all the way over to this line. So let me highlight the whole thing for you because it wraps around here. But you can see execute.bat being called and subsequently deleted. So this entire command line should be a pretty high fidelity way to determine that smbexec was used in an environment. You're also going to see cmd calling cmd/q/c pointing to, again, execute.bat. This is always present. And then you'll see cmd spawning conhost, always present. And then for every command entered into the interactive shell, you're going to see a 4688, and you're going to see your command inside of a 4688 in this kind of format where you've got cmd.exe/q/c echo command, which is the command that you typed in, like in my case, hostname, and then this entire string here, again, facilitating the use of execute.bat to go and execute the command I typed in. Make sense? So let's kind of weed out the noise here. Let's go over to this log. Let's go to security. Let's do filter current log, and let's just filter directly on a 4688 here. And we'll make sure that we're looking at the very newest. So let's go down to the newest one in the 919 minute. And you can see right here, the process command line is cmd.exe/q/c. So there's the echo CD. Did you see me type CD into the shell? No, you did not. That is there by default. Notice that exact string that I specified in the text document, right? If we go up, you'll notice cmd spawning cmd calling execute.bat. Then you'll notice cmd spawning conhost. Then you'll notice services spawning cmd, and check it out. Echo host name. So right after the word echo is the command I typed in. Of course, I did not type in the caret redirect. All of this to the end there after hostname is part of the command itself that the tool put in, not something I typed. In other words, I only typed in hostname right here. If I could highlight that, there we go. That's what I typed in. I did not type in this part to the right of that. So that, again, is a very high fidelity string to search for. If we go up, you can see again cmd calling execute.bat, cmd calling conhost, then cmd finally calling hostname, which is the command I ran. So if you map this out, that's a pretty clear indication, right? Let's go back and look at it from the beginning. All right, so the first thing we saw is services calling cmd where it's running echo CD, right? Then you saw CMD running execute. Then you saw CMD spawning conhost. Then you saw services spawning CMD, echoing the command that I typed in this case, host name right here, followed by everything to the right of the word host name right all over here. So you have all of that. Then we had CMD calling execute, CMD calling conhost, CMD calling hostname. So this one is definitely one of the more easy ones and high fidelity ones to detect. So again, with smbexec, BTO, and execute.bat are telltale signs that this is in use, as is this very long string, which is always going to be present. It wraps all the way around to here, as is this format where the word command that I've typed out here is substituted with the command that the attacker has actually typed into the shell. Makes sense? All right, and then lastly, let's talk about wmiexec. Wmiexec is pretty easy. We've got Python, wmiexec.py, again, the authentication at the target, and then system info. Notice that I said you can specify a command to run, or you can leave it blank for shell, much like dcomexec and psexec. So you can leave it blank and get a shell. In our case, we're going to be using system info again, because why not? Let's go back to our Windows 10 machine here. Let's right click, press enter. So we'll see the SMBV 3.0 dialect used, and let's wait a few seconds. Remember, this is being done in real time, no fancy video editing here. So here we go. There are the contents being returned to screen. So this is system info being written right out to the screen. So what should we look for on the target? Well, we will have, surprise, surprise, a 4776, 4672, and 4624 type 3. Again and again and again and again. There was like 5 or 6 rounds of this every single time I tested this in a lab environment from a Windows 10 machine to a 2019 server 2019 machine. I'm not saying that that's always what you're going to see, but just know that you will see at least one round of these 3 event IDs in succession, one after another after another. Then finally, if 4688s are enabled, you'll see wmiprvse, that should come as no surprise, calling cmd.exe, and then you'll notice this, again, pretty high fidelity command line. And this is always going to be present. This is going to change because this is the epoch time, as you can note right here. So this is actually, the Linux epoch time, which is the number of seconds elapsed since January the 1st, 1970. That is actually the timestamp associated with this. So you could convert this and determine, in my example, when this particular example command was run. So this will be variable, but certainly this part all the way over to here will be a pretty high fidelity indicator, something you could look for in a sim, for example. So again, wmiprvse spawning cmd, running, what do we have? cd \, cd, and then finally the command. So again, even though I did not type cd \, and cd \, and cd are there. So these 4 lines that I've highlighted should occur no matter what. cd \, and cd. So we've got wmiprvse spawning cmd, running that command, then cmd spawning conhost, then wmiprvse spawning cmd, running just cd, and then cmd spawning conhost. So that should always be there. Now we get into the execution of whatever it is that I gave it to run. So it's going to be wmiprvse cmd.exe. Command, in our case, would be system info, because that's the command I gave it. And again, this same high fidelity indicator here. So if you see these command lines on your target, and you see cd \, and cd, the thing that follows the cd is probably going to be the command or commands entered in by the attacker, right? Because anything that they ran would come after that cd \, and cd. So you should actually see that right there. And so let's just make sure that holds true. So let's go over to our server 2019 box. Again, the security log is here. 919 was the most recent. I'm going to refresh this right quick, and we should be able to get a pretty good indicator here. So let's go down to, all right, so the first thing is at 9:25:58. You'll notice right here, and you see cmd.exe spawning cmd.exe/q. There's our cd backslash, which again, you did not see me type in cd backslash yet. There it is, right? So let's go up another one, and this is cmd spawning conhost. You already know what should come next, right? Just the cd, and there it is, cmd.exe cd, right? And then we should have another conhost. There it is. And now we should have the command I entered. Yep, there it is, cmd.exe/q/c system info. That's the command I gave it. Then we should have cmd spawning conhost. Then what should we have? We should have system info, right? Well, yep, there it is. There's cmd spawning system info. In this case, the process command line was literally system info. That's all I gave it. This is a very high fidelity way to detect wmiexec. I think you'll agree. So again, cd /cd and then the command. Of course, we'll have a 4634 type 3 for the log off. And then let me also point out that it may be present 5857 and 5858 within the wmiactivity log. Let's go back over to wmiactivity. Let's go ahead and refresh this and see if we have any such log. So I do see 13cube/Bobby, and I see some WMI related information here. This is a 5858. This is a 5857 and a 5858. So I do get some WMI related logs located here. Again, depending on exactly what's happening, what commands are being executed, what operating system is configured, and how it's configured. This may vary, but just know that the Microsoft Windows WMI activity operational log may also have some content that will be useful for you, especially considering this is wmiexec.py and is using WMI under the hood, specifically wmiprv.se, to facilitate the execution of the commands. All right, so that was a lot of talking and a lot of going back and forth. I hope it made sense. This video is obviously a bit different than others in that this is not a nice, screen recording that's been voiced over with, clear steps one after the other. This is kind of a do it live kind of thing, right? We're actually looking at this in a nonstop recording in a lab environment. There's no magical video editing going on here. It's just switching back and forth, showing it to you live. This is what you can expect to see. Again, don't worry about taking screenshots. If you look in this video's description, you'll find a cheat sheet for all of this stuff where you can find out exactly what you should be looking for on a target system for atexec, dcomexec, psexec, smbexec, and wmiexec. So our 5 Impacket utilities that can be used to remotely execute commands. All right, so I hope this information has been useful for you. I would be very interested to see if you guys watching this have any kind of comments about additional things that I may have missed or other things that we want to add. I'm certainly not going to go back and edit or update an update to this video, but what I will do is update the cheat sheet accordingly. So if some of you out there have other tips and tricks for additional event logs to look at or other indicators to look at, we can certainly add them to the cheat sheet and kind of make it a growing, evolving document, if you will, because that's certainly a lot easier to update than it would be to remake an entire new video showing all this. But hopefully this will get the conversation started and kind of get the community involved in making a cheat sheet for this, because as of now, until I made this one, I had not previously seen one. So hope this helps. As always, thanks for watching. If you haven't already, please consider subscribing to 13Cubed. It helps the channel grow. Helps me out a lot, and I would greatly appreciate it. Also, check out the Patreon for 13Cubed if you want early access to this, because the Patreon people are watching this weeks ahead of when you're actually watching it, if you're watching it after the public release. So get early access and a lot of other perks, so check it out. All right, thanks for watching. Catch you in the next 13Cubed episode.